morning to you all. This is second module, second lecture, and today we will discuss about understanding program structure. Just a quick update. I have updated contents from week 2 to week 4, especially workshops, and they are uploaded. Okay. So only week 5 is left behind, which I will update very soon, and I will inform you through email or in the lecture. Okay. There might be some tweaks within the lecture contents, but those will be very minor. Okay, so this is one quick update. Okay, so in today's lecture, what objectives we want to achieve is, first of all, we will describe what are the features of unstructured code, spaghetti code. How we can say on the basis of what feature we can identify whether this code is spaghetti or not. Okay, and in order to address that scenario, we need to know about structure as well, and we will look at 3 basic structures that basically your program will consist of. Okay, and with these 3 building blocks, you can build complex logic for all possible scenarios which you encounter. Then we'll look at the concept of primary read, especially in case of loops. Sometimes loops become infinite. So there are certain best practices that you can take into consideration in order to avoid those scenarios. And these discussions we are doing in the context which we discussed last time. And last time we discussed that the programming process consists of 6 steps. It starts with understanding the problem, and then you go to plan the logic. But how do you know? How you will know that you understood the problem well? Can someone answer that question? How will you get an idea that, okay, I understood the problem well? Yeah, you have to conceptualize it and put it in a paper. The flow chart, pseudocode we discussed, and you can share it with a client. And client says, yes, this is what I want. So there is a feedback loop. That feedback loop gives you confidence. Oh, I understood the problem well. If client does not understand what's going on, it means there's something wrong in the logic. You don't understand the problem well, so it could be iterative in fashion. So in that regard, in that context, we will be discussing about the structure, what's important in the logic. So we will try to appreciate and recognize structure in the program. What are the advantages we get when we structure the program very well? In the last lecture, we discussed procedural programming and object-oriented programming. So there is also structure involved with object-oriented programming. We said that objects are the one who will be in control of their behavior, who will be in control of their data elements. If someone else needs the information, the object which is responsible for handling that data, responsible for their behavior, other objects need to talk to that object. Okay, so this is a structure we brought in the programming paradigm. So over here again, we need to recognize the structure within a program. The program we are building, does it follow a structure or not? And we will also look at different looping structures. We all know that programming languages in general have for loop, which starts with I is equal to 0, I is less than x, I plus plus. This for loop is common. We know while loop, while, some condition and brackets. We also know there is do while loop. So do you know the difference between while and do while?
So you do the structure first, and then you check the constraint at the end.
So you execute some instructions, and then you check the condition, and we will discuss this in today's lecture. And there's do until as well only in VB script, VB.NET. You will not find do until in C# or I think not in even PHP. Okay.
Is that the same as while?
Yeah, it is. Yeah. I have one example I will show you, but this is in specific in VB script. But before going into this, I just want to quickly introduce you to HTML, JavaScript, CSS, and PHP language and ASP.NET, because I know most of you are not coming from web development background. For some of you, HTML is a new thing, so that's why this will be a quick introduction. Before going further, first of all, we need to understand what is different between server-side programming language and client-side programming language. So does anyone know what's the difference?
Front-end and back-end programming? So like
Not necessary. Front-end you can create with server-side programming language as well. Yep.
sounds like C#
client side is C# and
I think that Java is one, two, maybe.
Java or JavaScript.
Yeah. And then server side's like .NET and all that stuff.
Server side is .NET, yes. But client side C# is again .NET. So it's on those both sides. No. Jacob, did you raise your hand? Or I thought you raised your hand.
I have guessed. I'd say that client side's compiled on your local computer, and the server side uses a computer elsewhere.
Logically, it does make sense. As the name says, client side is something on the client side. It does not have anything to do with the server. It's on the client side. And client side, what we have? A browser, only browser, and nothing else we have on client side. So something which is resided on client side, we call it client side programming languages. So how many of you have know about JavaScript, or you have used JavaScript in any of your project? Okay, so JavaScript is basically a language which runs in the browser. So we call it a scripting language. So JavaScript is a language which is client-side language. It runs in the browser. Your browser does not need to install something extra, like for .NET we need to install a compiler. For PHP we need to install an interpreter on server side. For JavaScript, browser understand it. So the languages like JavaScript that runs in your browser on the client side, even if you're not connected to the internet, they are called as client-side languages. And JavaScript, for example, and all the programming languages which PHP, ASP.NET, VB.NET, they are server-side programming languages. So when you access some program, the JavaScript files get downloaded on your machine, and then they run. Whereas in case of server-side programming, you submit the code to the server, and server basically processes it and gives you the output. Okay, so there are various YouTube videos I have provided you for you to go through, and by going through these videos you will see that the things which we discussed in last lecture, that now there is computing power. There are technologies like JavaScript APIs, D3, AngularJS, that basically provide very enriched intuitive interface for web-based application development. So today we have web application development that are very data-driven, very enriched data-driven applications. Okay. Whereas a decade ago, maybe 8 years ago, these data-driven applications where we need to work with massive data set, they were mostly desktop applications. Okay, so do go through these videos. Okay, so HTML is hypertext markup language. So you know the links, they can connect the documents. So that's why this name was given to this language. And Tim Berners-Lee was the one who basically developed this language and along with the concept of World Wide Web. So it started in 1991 and it goes through various iterations, and nowadays HTML5 is being supported by most of the browsers, okay, but still not 100% supported by all browsers. But you can see it has evolved over a period of time. Initially HTML was not very strict with respect to structure. Now if you look at HTML page, we have HTML tags, then we have body tags, then we have table tags. Within table we have rows starting with TR, and within rows we can have a column which starts with TD and so on. And each tag needs to be closed as well. If it does not close, it should give an error. But initial version were not very strict. Even if you don't close some tags, still it will be able to render the page and display it to you. But XTML was the one where structure was strictly enforced. Okay, and things depend on what type of structures you want to enforce. And I will discuss one case of DTTs on upcoming slide. But anyways, HTML5 is the newest version, and it's the most advanced version of HTML, and it basically compatible with the previous version. Okay. It comes up with new tags. So in previous version of HTML, if you need to incorporate a video in your website, you need to do some programming on server-side programming. You need to create embedded maybe some Flash object to run a video. But in case of HTML5, you have a tags. With using these video tags, you can define a source, which video you want to play, the path of the video, and if video does not display run, what message you want to display. So all this is now within the HTML. A control has been defined, and browser know what does it mean. So this is advancement in HTML5, and most of the browsers are basically providing some support up to a certain level. So the goals of HTML5 is basically support all the pages, whether they are developed in HTML2, 3 or HTML5. And objective is to reduce dependency on external plugins. Okay, if you want to run videos, you may need some ActiveX control objects in the previous version of HTML. But introducing these video tags, now your dependence has been reduced. Okay, and your application can run easily in the browser. So relying on third-party components again may put your application on risk if there's some loophole in those applications, and they may run your application may run into certain risky situations. One other important feature is semantic definition of the tag. Okay, when search engine basically rendering the web page, it look at the metadata. Metadata is the tag within the head body of a web browser that tells the search engine what is this page all about. So if you look at the view source of web pages, you will see some meta tags. Okay, author is member of IEEE. Okay, so that tag basically tells the search engine what it is all about. But now in the latest HTML5, we have more meaningful tag, and if I can show you example over here, these tags are supported in HTML5. Okay, so when search engine would be searching something regarding article, and article tag is over there, and there is a title tag over there, search engine can better retrieve the result, and precision will be high, and there will be low recall. Platform independence, no matter which device you're running on, web page could be rendered, and there are better ways of handling the errors in HTML5 version. So this is the previously, if you want to enforce a structure on HTML, you need to define data type definitions. What I mean by person tag, you can define it, and then you can enforce a definition within the HTML. So we don't need to do this anymore. Okay, and tags are now simple. So that was HTML. HTML is client side. It runs in your browser. Okay. Now JavaScript. JavaScript is basically, it's not a Java. Java is programming language which is a compiled programming language, where JavaScript is a language you should run in your browser. It's client-side scripting language. Okay, most of the validation which alerts pop-ups you get are basically built in JavaScript. So it provides computational capability within the browser. You can play with your web page on browser side using the JavaScript. Okay, JavaScript helps you to interact with the web page, change the feeling of web page on the run, okay, and so on. Track the movement of the mouse. This is JavaScript. If user want to close the window, you want to give some alert to the user that this is another deal we are offering. Do you want to get this deal? So all the events that are related with the browser basically are coded behind the scene, are being coded using JavaScript. They are captured, they are handled using JavaScript. So they on window close, on key press, on mouse exit from the text field, or mouse focus on the text field. All these are events that are basically can be captured using JavaScript. Okay, as I mentioned, control appearance, control the browser, interact with the user, also the cookies. As we discussed last time, session variables like a visiting card. Sometime those applications that need your identity, they also save some information on your machine, so that when next time you come to access our website, we can read from your system, from these cookies, which we call them cookies, what was your last date, what is your unique ID, what did you search on the website last time, and we can use that information to present you something latest, or maybe you can start again where did you left before. Okay, so all this can be done with using JavaScript, but what it cannot do is working with the files. Okay, you need programming language, you need to create files, you need to read from file, you need to read from the database. Can we read and write to the database using JavaScript? No, because database would be on another machine. Okay, and JavaScript cannot connect to the databases, but we will see that through calling certain pages which will have certain programming language, compiled programming or interpreter based programming language, they can access the code and so on. So the syntax is very simple, like C#, PHP, similar syntaxes follow, brackets for if, loops, so everything is very simple. And asynchronous JavaScript. Have you heard of asynchronous JavaScript? No. So when you type in Google, you just press key N, you will get some hints. And you can click one of those hints to search the results. Now behind the scene, what happens when I press N, a query basically goes to the server and JavaScript is doing it. JavaScripting is basically sending some information to the server and server is giving some results. So behind the scene, JavaScript is basically working and providing you the result, but we cannot see because page is not being submitted. So when page is not being submitted, we call it asynchronous JavaScript. Okay. So if you look at the view source of simple Google page, the search page, you will see there will be a lot of JavaScript over there. And if you search key press event, you will find key press event over there. Okay, and so on. Cascading style sheets. Again, these run on the client side, on the browser side, and these are meant to give styles, appearance. Give appearance to your web page. Okay. Although we have tag like H1, H2, P, unordered list, ordered list in HTML to give some structure, appearance to your web page, but these cascading style sheets provide you some leverage. And what is that? Designers and developers can work separately. Okay, so instead of working on same file, because HTML file contains JavaScript, okay, and you can link the file. You don't need to code everything within the web page. You need to code some code, but also you can include the APIs. Similarly, for CSS, you don't need to code within the page. You can create a separate file for styles, and then you can link that file in your HTML page. So the HTML designer, the developer who's working with the HTML page, he don't need to bother about styles. Okay, he knows styles will get from this file. And the person who's working on style files, he knows that there will be a field, text field, and I need to change the color background of text field from white to yellow, for example. Then he can define those styles in this styles.css. So by linking this file, all the things which have been defined in CSS file, they will get applied to this your code, HTML code. Okay. For more information, I have provided some links. You can go and read further. So there are different ways style sheets can be applied. One is external style sheet. You define it a separate class. Second is you define within the head tags of your file. And third is you define within the control. For example, input control, text field. You can define styles within the text field tags. So there are different layers you can define, and you can see further information on this link. So when you can define styles on multiple levels, it could be external, it could be on top of your web page, or it could be within the control, then which style should get applied? For example, against one text field, style has been defined in the CSS file, which is external. A style has been defined which is on top of the web page, which is head section. And the style has been applied even within the control, inline style, we can say. So which will get applied? Again, the one which is applied within the control, it will get precedence. Okay. So the one which is defined within the control, it will get precedence. Then the web page, then the external. Okay. So if within the control there is also HTML tag, that HTML tag will get preference. Okay. So this is the order of precedence. So that was quick introduction, and we will not be playing too much with HTML. In first half of this course, we are retrieving information from HTML control. We are not retrieving information from web forms, which we will discuss now. So ASP.NET, we all know this is technology provided by Microsoft, and it's basically on .NET platform, and it was a big shift for Microsoft from previous VB script based classic ASP based application. Why did they do that? How many of you know about VB6? Do you heard of VB6? VB6 was basically drag and drop desktop applications, and you can build applications very quickly. There were crystal reports tools that you can create reports very quickly. So in short span of time, you can build a very good application for your business. That's why VB6 was very popular. Okay, but VB6 cannot be used for developing web application. So that's why Microsoft take a big shift, and they came up with .NET framework. And what it does, it provides a common language specification. There are more than 20 languages supported by the .NET platform. Okay, C#, C++, VB as a language, J#, there's F#, and so on. Around 20 languages. But all those languages are mapped to one specification. Okay, syntax varies, but semantics are same. Okay, loops, syntax could be different, but semantics are same. Loops will work in the same fashion. And then they define set of classes that can be used in web-based forms. Those are web applications, also in .NET applications. So for example, ADO.NET, they are very defined packages, and in .NET we call them namespaces. We all know about packages. Package is a set of classes that are coupled together that do some cohesive task, and we can reuse those classes in our program. So so in this case, in .NET we call them namespaces. Okay, so these namespaces, for example, system.data is one of the namespaces which you will use in next workshop. Okay, so they could be used over here and over here as well. And all these classes basically eventually will be run by this common language runtime. So if you know about Java virtual machine, this is exactly the same thing. Okay, so this is like JVM over here. Your code get compiled and JVM run. Similarly, your language code will get compiled and will be transferred into common language specification, and eventually it will be run by common language runtime. Okay, so it's a server-side technology. It's compiled in nature, and in ASP.NET web application we have web forms. Now, what is different between web forms and the web pages which we are creating in our workshops, which you will be creating in today's workshop? Now, web forms basically contains advanced controls. In HTML, we have input control like text field, and it has few properties: ID, name, and value. Okay, you can give him an ID, you can give some value, that's it. But in case of web forms, Microsoft basically extended that control and came up with a text box. So in web form, when we will do, you will see that instead of text field, we will be looking at ASP:text box, and it will have various properties. Okay, and using code behind, which will be a C# class, we can access the web controls. So in short, Microsoft extended the existing HTML controls to a great level so that we can build applications quickly, like we used to do in VB6. In HTML, we don't have data grid control. We have a table, and we have to define table tag, rows, and so on, and we have to manage manually. But in case of web forms, we have data grid control. And with data grid control, we have only give them a data, and it will display it. Okay, so this is a big shift. So when you will do your second assessment, you will realize how much technology shift happens when you will doing first assessment and the second assessment. So web form is basically visual drag and drop. Okay. PHP, it's open source technology. It's a programming language, and it's freely available. You don't need to pay for any license. And most of the medium to small scale organization, especially web application development, they prefer PHP language, along with Apache Web Server and MySQL database, which are also open source. So this is very popular, and the only issue is sometimes if application logic is getting bigger and bigger, it's more compute CPU intensive. Okay, but this is open source. There's open source community that basically support this language. So this was quick introduction to give you some idea about HTML and other client-side technologies, and PHP and ASP as well. Okay. Any question? No? Okay, so now we can talk about the spaghetti code, which we discussed, that it does not follow structure. We all do coding, and whenever you code your first program, it looks like a spaghetti code. You don't know what is happening. You keep on coding. You keep on writing the code to make your logic working, but eventually you end up with a big chunk of code, and later on you realize that, okay, I should not have done this and that and so on. Okay, so that is an example of spaghetti code. Now traditionally, there were some features in the languages that basically put the developers in a dilemma whether they use it or not. If they use it, it results in a spaghetti code. And one of that example is goto statement. How many of you have done C++? So goto statements over there. You can go anywhere in your program. Go to line 1, go to this and so on. Similarly, VB, this statement was over there. So this is a simple program which is prompting how much cache do you need. Can you read? Okay. And then it prints something. But you can see, you can define a label somewhere, a position in your program, and using goto statement and referring to that label name, you can go over there. So in short, you go up and down, and it's very hard to understand what is happening. Okay. You run the program, you may get the logic, but if you put this on a paper, do you know what's happening over here? It's very hard to understand. So this is an example of spaghetti code, which is basically very poor design. If design is poor, then how do you know you understood the problem well? If you show this to the client, it's very hard for client to understand. Okay, so we need to avoid this situation, and we look at some best practices, some rules that governs how flowchart should be developed. This is another example. It's about washing a dog, which is it's a very simple activity, but over here it looks very complex. If you see over here, this oval shape basically tells the boundary of the program, start and end, and these rectangular boxes tell us some computation is happening, and these diamond basically tell us some decision is being taken, and if there is arrow coming back to this diamond, this shows a loop, that this decision is basically a condition for a loop. Okay, and we discussed this in the last lecture. Okay, so this is how this program has been designed in a flowchart. Can you identify some issues with this one that basically restricts your understanding of the program? If you're a developer, if you have to code this,
the decision is always the same. Almost, actually. Does the code run away? Does it?
so there is some repetition. Okay, that's fine. What else? If you recall, if you were doing UML and other analysis and design, you always start from the left, you go down or right. It's really you go up, backward. Okay, this is general best practice. In this case, it's going back. And in the last again week, we discussed that this arrow should go back, but it should not outline something. So these boxes should be down, and the arrow should be going from here to the question we are asking for. I have few more examples where we will emphasize this point. In short, they are crossing lines one over another, and it basically restricts your imagination to understand the program. Okay, for example, if dogs run away, then you go over here. But if dog does not run away, you go and do some task. But if run away again, these need to be implemented in if-else structure. And if this is a if, and you do something, then else is how you would include a else that will go to again to that function. Remember, this is not a module call. In this flow chart, we haven't mentioned there is a module over here. What we have mentioned, there is some instruction that computes something. Okay, so there is one instruction, and we are referring that instruction from two locations, and it's not a module call. For module, I will show you there's something else. So in short, there are issues when lines are interfering. You cannot basically dry run to the program. This is a spaghetti code. This is another example. This logic is very simple. On the basis of test score, we have to rank the schools. If score is between 90 and 100, then this rank should be given. It's simple if-else structure. But if you look over here, it's very hard to understand what's happening. Okay. So we should not get ourselves trapped into these situations. Why we have flowcharts? To better understanding. Okay, before going and programming something, you should develop your flowcharts, and flowcharts should be shared with your team members, with the clients, so that you can get some feedback. But if your flowcharts are like this, then you will run into trouble. So that's why we need to understand the feature of this spaghetti code. So it doesn't mean spaghetti code will not work. Okay, it often works, and because you have built your logic, but it's not built in the best way, best fashion. It would be hard to test that program. It's hard to fix that program, hard to maintain that program, hard to extend that program. So things would be very difficult. So in short, it will be a nightmare if you don't structure a program well. Okay. So the practice which we have, we start thinking, and in parallel we code the program. Sometimes it's very difficult for a person to go and design the program because he thinks logic is very simple. That's fine if you're doing that, you have maybe 5 years experience. But for a new developer, it's good to basically give some time and design your logic and then go and structure a program. And if you follow this approach, this will save more time. This will in fact save your time. Because in other case, if you start doing your coding and you're thinking in parallel, then you will end up with a code which is a big chunk. And rather than that, maintain that big chunk, it's good. You design your logic first, and you come up with a very structured modular code that is easy to maintain. Okay. So once you are able to develop your code, you test it, you submit it, and it's production. After that, changing that code is very difficult. Okay, if new developer change it, he may introduce various bugs into the program and so on. So it's a good practice to do it. So how we can bring structure in the program? So as I mentioned to you previously, that object-oriented programming brings in structure along with them, and there are many advantages. Similarly, within a program, we need to follow certain structures, and the three basic elements, three basic building blocks we can say are sequence, selections, and loop. Okay, so these are three building blocks. Using these blocks, you can build your logic, no matter how complex that logic is. And on this figure on right side, we can see that sequence is basically a set of instructions that will get executed one after another. Okay, then branching is basically selection, so if statements, and then we have loops over here that basically repeats certain set of instructions. So if you using flowcharts, then you need to follow standard flowchart diagram schemes. For example, this is a sequential flow of instructions, and we call it a sequence. The arrow is going downward. Really, you will see it going upward. Okay. So this is if statement. How if statements are presented in flowchart is depicted over here. So we have a condition. We can call it as question as well. And over here we are basically questioning a variable. And depending upon the value of variable condition, we take a course of action. If it is true, then do this. Otherwise, do this. And then when we exit the if statement. So this is how if is represented. And we have to follow these rules when we are designing our program logic. And this is simple if, one if. If this is true, do this. So this does not have any else over here. But you need to draw a line. So this is null else, you can say. Okay. But in your flowchart, this path should be mentioned over there. Okay. So in programming language, we have options that we can opt. But when we are designing the flowchart, we have to follow standard rules so that the other people who knows those standards, when they look at that flowchart, they are able to understand it, what's happening. So novice developers, what they do, sometimes if-else structures become very complex, like the case I showed you before, ranking of the schools. If it becomes very complex, then testing that program is very hard. Because in order to test the program, you have to execute each and every statement to make sure that program is working fine. So what they do, they basically code in this fashion. Instead of creating if-else structure, they only create if structure because it's easy. If variable gender value is f, do this. If it is m, do this. Instead of doing it this fashion. In this case, a simple example, but it could be complex. So which approach is better? Definitely this is better. But why this approach is better? Because this will work as well. Hmm? It's all the same statement? No. Functionally both are same. Functionally both are same. Both are doing the same thing. But this is better. Why this is better?
I disagree.
Yep.
If you haven't verified that their gender is equal to F or M, the one on the right will fail. We'll always execute show men's clothing, whereas the one on the left will fall through to a statement after those two examples.
Okay, so what point, I will come to that. What I am trying to say over here, that if this statement gets executed, then else will not get executed. We don't need to spend time. But in this case, every if needs to be checked. If it is variable gender value is f, this will execute it. Even value is f, but still this statement would be checked. Whereas in this case, if one if is true, then else of that statement will not get executed. Okay, so regarding computational side, this will be more efficient as compared to other scenario. But it doesn't mean that I'm saying that always do this. So it depends upon context as well. And developer is the one who basically make these choices depending upon context. As your fellow student mentioned, you can select the structure. So we saw sequence, we saw selection, and now we have loop structure. And this is how loops are represented on a flow chart. You have a diamond sign, and then you have set of instructions, which is a loop body, and it will go back again to the question. So question, execution of something, and then go back to again to question. So this represents iteration. And these are the examples of while loop. As long as some condition is true, keep on iterating. I'm sure all of us, we have used these loops before. So all logic problems can be solved using these three constructs. So if you're designing a flow chart and you know these three, how these three are designed on a flow chart, and you represent them well, then your team members can understand it, and you can easily communicate with your client as well. Now these three structures can be stacked up on each other, we all know, okay? And if I show you this example over here, so this is a set of sequence statements, and then we have a selection, which is if condition, and then we have a loop. So we can stack up them on one another, or we can nest them into one another as well. For example, over here we have if condition, and if this condition is true, we have sequence in there. Okay, so they can be we can nest them as well. We can also call this as a block of statements. Okay, and within that sequence we can basically nest a loop as well. So they can be stacked on top of each other, and we can also nest them as well. And on these three slides, I showed you some examples. So in short, these are the three structures which you need to understand how we need to draw them, what are the rules, and if you are able to understand them well, then you are in a good position to design your flow chart that can help you to achieve your objective. So you will see that each structure has some entry point and exit point. Okay, in case of sequence, the first instruction is entry point and the last is exit point. In case of if condition, the condition itself, where you're testing the variable, is entry, and this is how we show the exits of if statement. In the case of loop, again the decision, the condition which we are trying to assess, that is the entry point, and then we have a body of the loop and this arrow pointing back to start of the loop again, which is action. If we know these conditions and we know the rules, then we can basically stack them together. Most and through experienced developers, it has been mentioned in the literature that most of the mistakes which people do is basically how they should be stacked up on each other. How they should one should be attached to exit point of another control structure and so on. So we have to be careful of entry and exit point. For example, in the case of loop, this is the entry point and this is the exit point. Exit should not be somewhere over here. Your arrow should not be somewhere over here saying that exit the program. Okay, so we need to follow these rules. Let's take 10 minutes break. It's 11:10 now, and then we will start the priming read. So do you have any question? No? Okay, so let's take 10 minutes break then.